Hello everyone, welcome to Next Gen Network Engineers. Let's get started. So in this video, we are going to discuss about network reference model. Okay, so what is network reference model and why do we use and what are they? Okay, what is their importance into networking? So why do we have to know network reference model? Okay, these models when it comes to networking. So, network reference model is originally created for implementing a standard for interoperating between products. Between products, you mean like we have multiple products. Let's say we have IBM products, we have Dell, HP, different vendors manufacturing multiple devices. They will generally communicate between each other. So we know, right? Network means communicating between two or more devices to share some data. Okay, so if we have to communicate between two different devices, both devices, where whatever that device is, like it's made of Dell or HP or whatever manufacturer, they should follow same standards. Okay, so that's when we got two most important or most recognized network reference model. One is OSI, which is Open System Interconnection, and then another model is Department of Defense model. Okay, so these network reference models are organized into layers. Okay, both OSI as well as DoD model has a few layers. Okay, that is the representation of your networking function, which means like if you are transferring data, it's not straight away going from one machine to another machine. Okay, it's segregated into a few layers of functions that governs the end-to-end communication. So that is what called protocols. Okay, we have multiple layers. Each and every layer has different protocols. Those protocols will handle the data between those layers and deliver those data to the opposite layer in the opposite machine. Protocols on one layer will interact with the protocols on the layer which is above or below it. This forms a suite of protocols, protocol suite. Okay, generally we'll call TCP IP protocol suite, which is nothing but our DoD model. Okay, so what is a protocol? So protocols. So the protocols are the rules that govern how devices communicate and share information across the network. Example, we have IP protocol. We know IP protocol, okay, which is a layer 3 protocol. Then we'll go what is those layers. Okay, we have something called HTTP. We would have seen this. Okay, we know IP address. We know something called HTTP. We would have seen in some, in your browsers. You'll have something called address bar. You'll type something like this: https://www.google.com. Okay, so this is what your protocol. HTTPS is a protocol. Okay, this is used for getting web pages. Likewise, SMTP is used for transferring mails. Okay, IP is to deliver packets. Okay, so like this we have different protocols. We'll get into them whenever required. Fine, let's get into OSI. So OSI means Open System Interconnection. This model was developed by ISO, which means International Organization for Standardization, in 1984. Okay, they first provided this as a framework for governing the network, governing the entire network. This OSI is of 7 layers totally. Okay, layer 1 is physical layer, layer 2 is data link layer, layer 3 is network layer, layer 4 is transport layer, layer 5 is session, layer 6 presentation, and layer 7 is application layer. Okay, so we'll segregate this as top 3 layer, okay, and bottom 4 layer. Okay, why? Because this top 3 layer is actually into application side, which means let's say if we take an application layer protocol called HTTP, will take care of all these things. Okay, or if you take SMTP, okay, they'll take care of all these three things. Okay, so generally the part of a network engineer, the role of a network engineer will not go beyond this unless and until it's required. Okay, unless and until, okay, kind of a traditional basic network engineering concept. Fine. So What is this application layer? Application layer is the one really interacts with the application. Let's say you have a application called Chrome, okay, which is a browser. What it needs web content. What is the protocol you have to deliver web content? You have a protocol called HTTP. That's application layer protocol. Okay. Then you need to do some presentation. Let's say if it is an image, you have to do JPEG presentation. If it is a text, you have to manage that like a text, or if it is compressed, it's a zip, or if it is something else, like we have different encoding mechanisms like base 64 kind of things like that, or encryption, decryption, encoding, decoding. All these things are managed by this presentation layer. And then session layer, okay, you will create sessions, maintain sessions, terminate sessions, which means like close sessions. Okay, this is the part of your session layer. Okay, these three are called upper three layers. This is managed by your application part itself. Generally, developers majorly work on this, okay, or back-end developers or something like that. When it comes to next, okay, these application layer protocol like HTTP will hand over this data to the transport layer, which means like HTTP will hand over to presentation layer. Presentation will layer will do its job, and then it will hand over it to the session layer. Session layer will create session and hand over it to transport layer. What transport layer will do? Transport layer, it will create segments, which means if you have a big data, let's say it's a 1 GB of data, it's a 1 GB of data, you cannot send it just like that, because your speed will not, let's say you have 10 Mbps speed, okay, megabits per second or 100 megabits per second, okay, you cannot send 1 GB file just like that. Okay, so what your transport layer will do, it will it will cut this into multiple segments, small chunk of data, small chunk of data. Okay, generally these segments will be of size 1460 bytes. Okay, I'll explain this later why this is exactly 1460 bytes. There is a value called maximum segmentation size, okay, which is MSS. That's why this creates this 1460 bytes. Let's say your application HTTP is trying to download 1 GB file. That 1 GB file is getting into small segments of 1460 bytes. Okay, so you got now lots and lots of small segments like this. Okay, each and everything is of 1460 bytes of information. Okay, over this, what your network layer will do, network layer will uh, will send it actually. So what your transport layer actually will do, transport layer will add a header and then it will hand it over to the network layer, which means this is your data, okay, of 1460 bytes. It will add a header, which is your layer 4 header. Okay, that will be of 20 bytes. 20 bytes layer 4 header. Okay. Then it will hand over this to your network layer. Network layer will add its header, which is layer 3 header, layer 3 header, which is in layer 3. This is also of 20 bytes. Okay, this is 20 bytes, this is 20 bytes. Okay, so totally you will get something called a packet of 1500 bytes. This is what called maximum transmission unit. Okay, which mean what is this maximum transmission unit? Is this is the default size of data which can be transferred by any machine by default, like any normal machines. Like some machines will support jumbo size. Okay, we are not getting into that topic. By default, most of your routers, laptops, servers, machines, everything would have configured to use this 1500 bytes as the default maximum size it can transfer. Let's say like you can compare with you have a house, you have a door frame like this, right? If you have something like you have a cart which is bigger than your door frame size, what you have to do? You will dismantle them, and then you will uh, take this inside, right? The same concept, okay? So this network interface is of 1500 bytes. This is what the maximum transmission. This much data can only be transmitted via this interface, okay? So whatever you have data, it can be 10 MB, 100 MB, 1 GB, whatever, it has to be cut into small chunks of 1500 bytes, okay? 1500 bytes. Fine. The network layer, okay. In transport layer, we have two protocols called TCP and UDP. And in network layer, we have IP. That's the only protocol which we use majorly. And then network layer will hand over the data to data link layer. Data link layer here, it will add 18 or 22 bytes. Depends on what you have. Okay, so layer 2 will also add. Okay, we'll get this data deeper when we discuss about Ethernet, IP, TCP, and stuff. Okay, just a rough idea what this OSI layer actually is. Okay, so this data link layer. Okay, this is actually Ethernet we generally use. Okay, this will add a header with source MAC, destination MAC, and all those things. Okay, and then this physical layer, it will not hand over to the physical layer. Actually, data link layer will send it out. Okay, which means like handing it over to the physical layer means this will send this as a signal. So let's say kind of a digital signal, if at all like this, or some analog signal, something like this. Okay, so here you just have bit streams. Got it? Um, so you see here we have 7 layers, right? We don't have any name of this data unit, which is protocol data unit. We don't have any specific name for application, presentation, and session layer. But in transport layer, we call it as segments. In network layer, we call it as packets. Okay, routing packets. Okay, and then like creating segments, TCP segment, UDP segment, like this. And then data link layer, we call it frames. It's a Ethernet frame. And then in physical layer, it's called bits. It's a bit stream. Fine. So this is how the exact encapsulation and decapsulation happens. Let's say you have the same 1 GB of data. Okay, so that is given by this application layer to your transport layer. Your transport layer will cut it into small chunks called segments. Okay, each segments will be of 1460 bytes. This is 1460 bytes, and then it will have a transport layer header with source port, destination port, and stuff. So we'll discuss that in while discussing about TCP and UDP. So this will be of 20 bytes, and then it will hand over this to your network layer. This will add its header of 20 bytes, and then it will hand over that to data link layer. That will add its header as well as trailer. This will use header as well as trailer, which is actually uh, 14 to 18 bytes of header and a 4 byte trailer. Okay, so trailer is actually added at the end of the frame. Okay, and then that's it. This will be sent in the physical medium as bits. Okay, once your receiving host detects those bit streams, let's say that's 101101000, something like this. Okay, then it will see, okay, we have got this much of bits, then let's convert that into some hex and then create some meaningful information like that. It will take this F14 to 18 bytes as layer to header, and then it will take the 4 bytes at the uh, as a trailer. Okay, this is a checksum we have. Then it will see, okay, next we have 20 bytes network layer header, 20 bytes transport layer header, and then 1460 bytes of data. Okay, so Ethernet, which is our layer 2, will hand over this data to your network layer by decapsulating. It will take this off. Okay, when the layers give data to other layer, it is encapsulating. See, application layer is giving data to transport layer it's encapsulating the data with its header and then handing it over to the network layer is encapsulating with a new header and then handing it over to Ethernet is encapsulating. Okay, like the same wise, the vice versa is happening. The network layer will decapsulate and then take its header off and then hand it over to the transport layer. Transport layer will take its header off and hand it over to the application, which means it'll have all these segments, right? Let's say this has 100 segments. The transport layer will wait and accumulate all those 100 segments and then give it to the application. Got it? This is what your OSI layer does. Okay, so this is an example of your OSI reference model. Application layer uses HTTP, and then your presentation layer, it takes care of this presentation like HTML, XML, PHP, GIF, JPEG, or encryption, whatever mechanisms you use. And then the session layer is responsible for establishing, maintaining, and terminating the sessions. And then your transport layer, okay, if you are using HTTP protocol, HTTP uses TCP as a transport layer protocol. Okay, and then in network layer we use IP will take care of handing over the data from your PC to the end. Let's say you're downloading something from Google, from the Google server to your laptop, your IP will take care. Okay, but maintaining or taking care of this reliable data delivery will be taken care by the TCP. But whatever TCP gives, IP will hand over it to from end to end. Okay. This data link layer will take care of the uh, data delivery between two different ends. Let's say your PC is connected to your Wi-Fi router. In between these two, your layer 2 will be taken care. Okay, then physical layer is just raw bits, nothing much. It's like signaling and coding mechanisms in physical layers and stuff. Okay, so we have this something called DoD model. Okay, when comparing to this OSI with DoD, you see this all these three layers are shrunk into one application layer. So while looking into this, you will now understand. Okay, this is when he said HTTP will take care of everything. Yes. Okay. Why? Because OSI layer is most of theoretical into textbook. This has lot of detailed information. But when it comes to real world development, most of the developers use TCP/IP protocol suite, which is nothing but DoD model, which is developed by the United States Department of Defense, US DoD. So this transport layer is called host-to-host layer in this DoD model, and the network layer is called internet layer, and then this data link as well as physical is shrinked into single layer, stating network access layer. Okay, so this will be very much clear. HTTP will use TCP, and then this use IP, and then this use Ethernet. So here you can see the consolidated model, okay, which is like how this exactly, as I mentioned, whatever application layer protocol you use, FTP, HTTP, or SMTP, or any other things. In host-to-host layer, nothing but the transport layer, you use TCP or UDP, and in the network layer, which is internet layer, you use IP, and then in network access layer, you use Ethernet. Fine. So in practically we use this DoD model, or we call this as TCP IP protocol suite. Okay. Uh, very much this is practical. But when it comes to theoretical, everywhere you see OSI layer. Okay. The OSI layer generally it's kind of something holy when it comes to textbooks. That's it. If you have any doubts or you need more clarification or you want this to be covered very much detail or very simple, you can post in comments. We'll discuss on some other topics in some other video. Thank you.